Hi, boys and girls. We are on lesson 7, problem set. This is page 39, and it says Jeffrey builds rectangular planters. So this is a planter that I drew. It says for number 1, Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. So it is filled with 3 feet of soil. What is the volume of the soil in the planter? Explain your work using a diagram. So I started to draw my rectangular planter because it's a planter, it's rectangular. And now I'm going to draw the soil. So this is going to be my soil, and I'm going to put a little arrow so you guys know that is the soil. Now, on one side we have 8 feet long. So that is the length of the diagram. So right here is going to be 8 feet. And next it says 2 feet wide. So that's how the width would be, 2 feet. FT stands for feet. And then it says the height is 3 feet. So the soil height is 3 feet. So I'm going to write 3 feet on this side. Okay. Now, I know that volume is equal to length times width times height. Okay, so I'm going to multiply my length, my width, and my height. My length is 8 feet, 8 feet. My width is 2 feet. And my height is 3 feet. Okay, so when I multiply them together, I know that 8 times 2 is 16, and 16 times 3 is going to give me 48 feet cubed. So there is 48 feet cubed of soil in the planter. So I can now write my sentence. There is 48 feet cubed soil in the planter. I solved the volume. Okay, can you guys kind of see that? Let me, I guess it doesn't zoom out any more than that. Okay, problem number 2. I wonder if I clicked on the wrong settings. Is this one the one? Oh, there you go. Now you can see. Okay, problem 2. Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planters' measurements on them. So I'm going to make sure that I draw a diagram for different ways to get the same solution, 320 cubic feet. So I'm going to draw the first one. This is the first rectangular prism. And I am going to make sure that I'm multiplying volume is equal to length times width times height. So I'm going to do it by 10 feet times 8 feet times 4 feet. And that is going to give me my answer, 320 feet cubed. So you are looking for 3 lengths. That's going to give you 320 feet cubed, which tells you right there. So this is going to be my length is 10, and I wrote that my width is 8, and my height is 4. Okay, Now I'm going to move on to planter B. I'm going to draw another diagram. And this one is going to be very, very, very wide. Now it does not have to be perfect. Volume is equal to length times width times height. So my length is how long this is. So it is 16. My width is how wide something is. In this case, it is going to be 20. And then my height is going to be 1 foot. So 16 times 20 times 1 is going to give me 320 feet. So my 1 can go right here. Now, planter C. I'm going to draw this one a little bit longer. Okay. I'm going to make it 32 feet, 5 feet, and 4 feet for my height. So volume is equal to length times width times height. So my length, I said, was 32 feet. And then I said my width is 5 feet. And then my height is going to be 2 feet. So when I multiply that all together, I get 320 feet cubed. Now, my last one over here, I'm going to draw another rectangular prism. Okay, so I'm going to label my length 8 feet. And I'm also going to label my length and width 8 feet. And then my height is going to be 5 feet. So volume is equal to length times width times height. So when I multiply 8 times 8 times 5, I'm going to get 320 feet. Okay, now I'm going to turn to the next page. This is page 40. On page 40, it says Jeffrey wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground. If he wants the planter to hold 36 cubic feet of soil, name one way he could build the planter so it is not taller than 3 feet. Explain how you know. So, he wants to build another planter, which is another rectangular prism. Okay, and it says here that it is 3 feet off the ground. That means that the height is 3 feet off the ground. And then it says it's 36 cubic feet of soil. Okay, so we know that the numbers we need to have is going to equal to 36 cubic feet of soil. So volume is equal to length times width times height. And I know that 36 cubic feet of soil divided by 3, because there's 3 feet, is going to give me 12. Okay? And I know that 12, numbers that equal to 12 has to be 3 times 4. Right? So my volume has to be, length is going to be 4 feet, or it could be 3, it doesn't matter. And then my width could either be 3 or 4 feet. And then we have our height already, so that is going to stay the same as 3 feet. So I know that 4 times 3 is equal to 12, and 12 times 3 is equal to 36 feet cubed. Okay, now they asked me to explain how I knew. So Jeffrey knew the volume of his planter, 36 feet cubed, and the height. So I multiplied to find what equals 212. Problem 4. After all of his gardening work, Jeffrey decides he needs a new shed replace the old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. He realizes he needs a shed with 480 cubic feet of storage. Will he achieve his goal if he doubles each dimension? Why or why not? So I know that his shed right now is not big enough, right? So he wants to build a new shed so that he can have enough room to put all his things. So I'm going to write shed. The volume of the shed that we know right now is 6 feet, which is right here. And I'm multiplying it by 5 feet and then by 8 feet. Okay? And I know that 6 times 5 is equal to 30, and 30 times 8 is going to give me 240 feet cubed.